We do not know what we don't know. Introducing supernova, a celestial event eagerly awaited by astronomers and stargazers alike. Situated on the iconic shoulder of the Orion constellation, this red supergiant star, known for its brilliance in the night sky, is reaching the twilight of its existence. However, in late 2019, something remarkable happened. Betelgeuse inexplicably began to dim. This dimming was so striking that it could be discerned with the naked eye and continued to fade for several months, sparking concerns among astronomers that Betelgeuse might be approaching the end of its life cycle. Despite the star eventually regaining its normal brightness, further investigations using powerful telescopes revealed that Betelgeuse had indeed experienced a significant dimming event. As the star continues its journey towards the end of its lifespan, it is now teetering on the brink of a potential explosion, adding to the anticipation surrounding this cosmic spectacle. Join us in today's video as we talk about NASA's new warning about the Betelgeuse supernova explosion happening now. Betelgeuse, also known as Alpha Orionis, is the stunning ruby-red star that shines brilliantly on the top right shoulder of the constellation Orion, the Hunter. It holds the distinction of being the second brightest star in Orion, coming after the blue supergiant Rigel, and is often referred to as Alpha Orionis. Stars designated with a classification of Alpha are typically the brightest in their constellations, although Rigel outshines Betelgeuse in Orion. However, Betelgeuse's unique name, fluctuating nature, and colossal size make it a captivating subject for stellar studies and observations. With its remarkable brightness, enormous size, distinctive reddish hue, and intriguing name, Betelgeuse is one of the most renowned stars in the night sky. In fact, it ranks as the 10th brightest star overall and the 7th brightest star visible from many parts of North America, Europe, and Canada. Its prominent presence has captured the attention and admiration of stargazers around the world. The name Betelgeuse traces its origins to an Arabic phrase that translates to the armpit of the giant, despite astronomer estimates placing Betelgeuse at a distance of 430 to 724 light-years away from Earth. Its precise distance remains uncertain. Nonetheless, Betelgeuse holds a significant place in the celestial realm as the closest and brightest red supergiant star to our planet in our galaxy. Only 200 red supergiant stars have been identified, further underscoring the importance of Betelgeuse. Visible from a distance of 548 light-years, Betelgeuse dwarfs our Sun, measuring 0.5 times its size, with a solar luminosity of 126,000. However, it has a colder surface temperature compared to the Sun, registering at 3,600 Kelvin. Interestingly, even if human eyes were capable of perceiving light across all wavelengths, only approximately 13.3% of Betelgeuse's radiant energy would be visible in visible light. This speaks to the complex and intriguing nature of this stellar giant, which continues to captivate astronomers and stargazers alike with its enigmatic properties. In our night sky, the brilliance of Betelgeuse would surpass even that of Sirius, the brightest star in our entire celestial sphere. However, despite its immense luminosity, Betelgeuse pales in comparison to the sheer size of our Sun, with a radius that is approximately 764 times greater. To put Betelgeuse's colossal size into perspective, if it were to replace the Sun in our solar system, it would extend beyond the asteroid belt and potentially reach as far as Jupiter, engulfing the orbits of Earth, Mars, Mercury, and Venus. Its sheer magnitude is inspiring and underscores the immense scale of this red supergiant star. As a red star, Betelgeuse goes through a process of shedding mass, with about one solar mass being ejected as a nebula every 10,000 years. This material is expelled in all directions, forming a nebula believed to span 30 astronomical units AU, which is 30 times the distance between the Sun and Earth. Furthermore, Betelgeuse is enveloped by a cloud of material that is a staggering 250 times larger than the star itself, adding to its cosmic grandeur and mystique. A newborn star brimming with hydrogen forms in the core through the relentless pull of gravity. The intense pressure and heat trigger nuclear fusion, culminating in a dazzling explosion that yields helium. This fusion process unleashes an astounding amount of energy in the form of heat and light, radiating as photons toward the star's surface. As the star matures, its hydrogen-fueled window closes and helium begins to fuse with carbon. Over time, neon also reacts with carbon, ultimately leading to the formation of iron once all of the helium is consumed. However, unlike previous fusion reactions, the fusion of neon and iron does not release any energy. As a result, the star collapses under its own gravitational force, triggering a spectacular supernova explosion that is unmatched in its sheer power. A supernova is a breathtaking natural phenomenon capable of emitting enough energy to illuminate billions of suns. It is a testament to the extraordinary forces at play in the universe, showcasing the awe-inspiring beauty and immense power of stellar evolution. Throughout their life cycle, stars undergo a remarkable transformation in color, transitioning from young and hot blue stars to older and cooler red stars, depending on their stage in stellar evolution. Intriguingly, the ancient Greek scientist Ptolemy, who lived from 90 to 168 AD, described Betelgeuse as ruddy in color. However, Chinese astronomers 3 centuries ago noted that the star appeared yellow, suggesting that Betelgeuse may have previously been a yellow supergiant. Typically large stars, despite being only around 10 million years old, burn through their hydrogen fuel at a faster rate, resulting in a shorter lifespan. Betelgeuse is undoubtedly nearing the end of its existence. In contrast, our Sun, at approximately 5 billion years old, is still in its prime, with plenty of fuel left to sustain its luminous existence. The study of stars and their evolution offers a window into the awe-inspiring wonders of the universe and the vastness of cosmic timescales. Betelgeuse's potential supernova remains a topic of speculation as the star approaches the end of its lifespan. Notably, Betelgeuse exhibits 2 distinct cycles of dimming and brightening, with one cycle lasting approximately 100 days and another occurring every 5 years. This phenomenon is believed to be caused by the expansion and contraction of the star's outer shell, resulting in changes in its diameter and average temperature. In recent years, particularly in 2019 and 2020, there has been significant interest in Betelgeuse's unusual dimming, followed by a brief return to normal brightness, which may indicate that the star is nearing the end of its life cycle. Betelgeuse's enigmatic behavior has captured attention since ancient times, with inquiries dating back to the 1st century BC seeking to understand its abrupt fading and departure from its typical cycle. The study of Betelgeuse continues to intrigue astronomers and stargazers alike, offering glimpses into the mysteries of stellar evolution and the vastness of the cosmos. Betelgeuse's journey has taken it far from its original home in the Orion OB1 association, which includes the stars in Orion's belt. Currently, Betelgeuse is traversing the interstellar medium at a staggering speed of 30 km/s, creating a bow shock that spans over 4 light-years. However, measuring the size of this red supergiant star presents numerous challenges in astronomy. Betelgeuse's pulsating nature causes its diameter to change over time, while its optical emissions exhibit color variations due to limb darkening, making it difficult to precisely define its age. Furthermore, the circumstellar envelope CSE surrounding Betelgeuse, composed of ejected debris that both emits and absorbs light, adds to the complexity of determining the star's photosphere. Despite these hurdles, scientists persist in their quest to unravel the mysteries of Betelgeuse as they continue to study this enigmatic star and unlock its secrets. Observations of Betelgeuse's size are challenging due to variability across different wavelengths. Reported diameters can differ by up to 30 to 35% depending on the wavelength used. In 2009, the European Southern Observatory captured images with a very large telescope interferometer VLTI revealing a massive gas plume extending 30 astronomical units L from the star. This mass ejection was just one of several in Betelgeuse's atmosphere, equivalent to the distance between the Sun and Neptune. Astronomers believe that there are at least 6 shells orbiting around Betelgeuse. Understanding the mass loss during a star's final stages could shed light on the tragic fate of these stellar giants. Astronomers are fascinated by Betelgeuse, its atmosphere, and the mystery of mass loss in red supergiants, which affects galaxy formation. Advances in interferometric techniques may hold the key to understanding this phenomenon. In 2019, telescopes, including the Hubble, observed a significant event where Betelgeuse shed a substantial portion of its visible surface, known as a surface mass ejection. This unprecedented behavior has generated interest and raised questions among researchers. Ejections of the Sun's outer atmosphere, known as coronal mass ejection CMAS, are common, but Betelgeuse's SMME is unique. Betelgeuse's surface mass ejection emitted 400 billion times more mass than a typical coronal mass ejection, causing a drastic decrease in brightness from October 2019 to mid-February 2020, dropping from magnitude 0.5 to magnitude